Make a quick video about E or Z. So I know that some students came to me and they said, oh, well, all trans are E and all cis are Z. And that's wrong. That's not true. So all E are trans, but not all trans are E. And all Z are cis, but not all cis are Z. So all E are trans, but not all trans are E. All Z are cis, but not all cis are Z. And I wanted to give you an example of like just in general to see why we need E or Z. So if I give you this molecule here and you look at it, you're going to be like, I don't know if that's Z. I don't know if that's trans. And that's why we have E and Z. Because you're looking at the priority as well as the position. And trans and cis are only looking at position. E and Z taking into account the position, obviously, but they're also looking at the priority. What is the highest priority? And that's my focus of this video, of how you're going to determine what is your higher priority. So let's get into it. If you go to the periodic table and you look at bromine and iodine, bromine is 35 for the atomic number. Iodine is 53. So iodine is going to be your higher priority. If you look at fluorine and chlorine, fluorine is 9 and chlorine is 17. So chlorine is going to be your higher priority. Since these high priorities are on the same side, it is classified as Z. Okay, next one. So you have you're attached to a carbon here, and you're attached to a hydrogen here. Since I'm attached to a carbon, this is my higher priority. So in this one, I'm attached to a bromine, and this one I'm attached to a carbon. Because the bromine is going to have a higher atomic number, it is my higher priority. Okay, let's go to this one. A chlorine or attached to a carbon, chlorine. Okay. If you go to the next one, chlorine or attached to an oxygen, again, chlorine. Okay, so this one is E because it's diagonal from each other. And that's what I mean by opposite side. I mean like that they're diagonal. And this one is Z. They're on the same side. Okay, so let's go to this more difficult looking one. Okay, you have a chlorine here. This carbon is attached to a carbon. This one is attached to this carbon. That's attached to hydrogens. This carbon is attached to this carbon. That's double bonded to another carbon. So that this carbon being attached to another carbon, double bonded to that, is making it the higher priority. So this whole group would be your higher priority group. Okay. But I looked at the carbon specifically. Let me take off some of the highlighter so the fact that this carbon is bonded to another carbon is what made this your higher priority. Okay? Now, and that's what I mean. You're looking from what each thing is attached to. This carbon being attached to another carbon, double bonded to that other carbon, is what made it higher priority because this carbon here is only attached to hydrogen. Okay, emphasize my point. So again, this one is going to be E. So let me take off that. Now, this is attached to a hydrogen. This is attached to a carbon. So this is your higher priority. This carbon is attached to another carbon. This carbon is attached to a carbon that's attached to another carbon. So that's your higher priority. So this is going to be C. This is attached to a chlorine. This is attached to a carbon. Chlorine is your higher priority. This is attached to a carbon that's attached to an oxygen. This is attached to a carbon that's attached to two oxygens. And even if it was, for example, an aldehyde, let's say it's an aldehyde, because some of you are just thinking, oh, there's two oxygens, that's why. Yes and no. Yes, obviously, two oxygens is obviously going to be a higher priority because you're attached to two oxygens. But even if this was just an aldehyde, and for those of you that don't know or still what an aldehyde would be this. it would still be your higher priority. Why? Because you're double bonded to an oxygen versus this one being an alcohol. Okay, technically it would be, like this, but I think you get the point. It would only be single bonded to that oxygen. This one has a double bond to the oxygen. If it were an aldehyde, if I was changing out this group, okay, this is not what a carboxylic acid is. What a carboxylic acid is, which is what the example is showing, a carboxylic acid would be this, okay? And you're seeing 3 bonds. You're seeing the double bond to one oxygen and the single bond to an oxygen. But I'm saying if I switched out this carboxylic acid and put an aldehyde, this would still be my higher priority. I just wanted to give you that extra example. So this is going to be E. Okay. Now let's go over the last one. So let's say you have attached to a carbon. This is attached to nitrogen. Nitrogen's higher priority. This is attached to a carbon that's triple bonded to a nitrogen. This is attached to a carbon single bonded to a nitrogen. So this is going to be your higher priority. Again, they are diagonal, they're opposite sides. So this is going to be E. So last thoughts. All E are trans, but not all trans are E. All Z are cis, and not all cis are Z. If you like this video, again, please like, comment, follow, share, and let me know in the comments if you need me to do a part 2, if this video was enough for you. And again, happy studying, and thanks again for watching.